प्रॉपर्टीज, कुछ जनरल प्रॉपर्टीज बिफोर क्वांटम डिस्क्रिप्शन ऑफ स्कैटरिंग, जनरल प्रॉपर्टीज डिस्कस कर लेते हैं ताकि वी हैव a better correspondence between classical approach and quantum approach. बुनियादी तौर पर the scattering experiment is some experiment where we learn about the goals of a scattering experiment is to learn as much as possible about the interaction between incoming particles and the target particles, or the two beams in general, or two beams of particles, because in an actual experiment we do not have the stationary target particle. In fact, two beams traveling in opposite direction interact with each other. So the basic, in fact, goal of doing a scattering experiment is to understand the scattering the interaction phenomena. So one of the goals of a scattering experiment is to learn as much as possible about the interaction potential. So that is the basic idea. Uh, the parts of the potential that we want to probe depends on the sensitivity on the initial state of the particle. So, what are the properties of the initial state of the particle, and not only the initial state, but also the potential of the target particle. So, the parts of the potential that are probed, that are probed depends on the sensitivity of the initial state of the particle. So, what do you mean by the parts of the potential? So this can be seen as some effective potential for the collision, and this effective potential will be the sum of the two potential as the central potential V of R plus the potential which is due to this interacting particle expressed in terms of angular momentum. So this can be seen by considering the effective potential, the effective potential for the collision. कैसे कैसे लिखेंगे इसको? VL of R, which is equals to V of R, the central potential, plus the part of the potential, which is a function of the or angular momentum, VR square. Yeah, so this is basically, and uh, and you can substitute this VL of R, which is equals to V of R plus L square upon 2 ms square, into equation number 5, entering into the equation number 5 to get to know what is the potential involved in the scattering process. So इसको study करने के लिए, let's say we consider a potential plot of several in fact different choices of angular momentum, see which for which values of angular momentum the states would have interaction. Sorry, the particles would have interactions, and for which angular values the particles would not have an interaction. So let's say we consider some potential curve. पोटेंशियल कर्व आपको मालूम है पोटेंशियल फंक्शंस हम कैसे डिफाइन करते हैं पोटेंशियल फंक्शंस आर प्लॉट्स बिटवीन potential and distances between particles. So let's say we consider potential plots for some several choices of angular momentum, choices of uh, angular momentum. So a potential plot would be a plot between potential as a function of distance, inter separation distance between the two particles. So that could be something uh, like this. So we have on the y-axis some potential VL, on the x-axis, which is the distance between, which is, let's say, R. So we can think about the energy. So let me draw this and then I'll explain. So this is the energy, that is particle energy, that is incoming particle key energy. And then we could have a potential like something like this, or we could have a potential which is something, or we could have a potential, or we could have a potential where we have, so we could have potential something, or we could have a potential something like this. So corresponding to this, this is the distance R naught. Corresponding to this, we have a distance R1. Corresponding to this, we have distance R2. Corresponding to this, we have a distance R3. And these are not R3 and are not R1, R2, and R3. They are basically distance of closest approach. This curve is for L is equals to 0. This curve is for L is equals to, let's say, 1. This curve is L is equals to 2 units, and this curve is L is equals to 3 units here. So we have R0, R1, R2, and R3. ये क्या है? These are points of closest approach. Yeah. And so we have these potential energy curves. Now let's explain them. So ये हमने कहा ना कि हम plot करते हैं, potential plot करते हैं, and how do we plot this potential as a function of R? By taking different values of L, angular momentum. So angular momentum L is equals to 0, angular momentum L is equals to 1, angular momentum 2 units, and angular momentum 3 units. So there are several sort of observations that can be observed from such a plot. So several observations from such a plot. And what are those, in fact, observations? So let's say we start for a given particle energy. Given particle energy meaning we are talking about uh, here, so we have some particle with a specific energy. Let's say we start with some specific energy of the incoming particle. So for a given particle energy, if you increase the angular momentum, that is, if you increase the angular momentum, meaning if your angular momentum is proportional to b, yeah. So if you increase the angular momentum, you are increasing the impact parameter, and that would result in pushing the particle away from the center. So on the other side, if you decrease the angular momentum such that the impact parameter is decreasing, so in fact, if the impact parameter is decreasing, then you are saying that the particle with zero angular momentum will experience the full range of interaction because it is in a direct interaction with the central potential. Yeah. And so we have different cases. So first of all, we need to know that uh, for so for some specific for a given particle energy, let's say we call that as E, increasing the angular momentum. What do you mean by increasing angular momentum? I.e., increasing impact parameter. So an increase in angular momentum means the impact parameter is increasing, and this would results in pushing the particle away from the center of the force, away from the center of force. Yeah. So this is the basic understanding. Now, what do you mean by extreme cases or the middle cases? So the extreme case would be particle with zero angular momentum, and particle with zero angular momentum meaning that you are decreasing the impact parameter such that the incoming particle would sort of see the full interacting potential. Yeah. So number two हो सकता है particle with zero with particle with zero angular momentum. What does it correspond to? That would experiences the the full range of the interaction potential. Yeah. Then we would have some for strictly uh, short range potential. That is some value which is a middle value, strictly short range potential. There is a sharp where so there is a sharp decrease, as you can see. For a short range potential, there is a sharp decrease. Yeah. There is a sharp decrease or cutoff on the magnitude of the particle angular momentum. Particle angular momentum that can be scattered, can be scattered. Yeah, so this is basically the case, and from this, that is from these points, one can infer some limiting cases. So there are two limiting cases for the impact parameter. One of the limiting case for the impact parameter would be that B tends to 0, and the other impact limiting case for the impact parameter would be to B tends to infinity. So B tends to 0 का मतलब है कि the deflection angle angle theta is 0. Is 0 का मतलब ये that is the incoming particle is absorbed by the target. That is the potential is attractive potential. Yeah. So for the case of B tends to 0, the deflection angle theta जो हमने निकाला है ऊपर that would be equals to 0, and this would correspond to some attractive potential since there is no sideways force which is acting on the particle, hitting a spherically symmetric head-on sort of collision. Yeah. Similarly, for purely repulsive potential, theta किसके बराबर होगा? Theta would be equals to pi, and in that case, there would be this pi means implies that 180 degrees reflection or in fact scattering in the opposite direction. Since the particle is reflected backwards, so it means that theta would be equals to किसके बराबर pi. So for a repulsive potential, theta would be pi, and this would represent some sort of a reflection in the backward direction. And both these cases, theta is equals to 0 and theta is equals to pi, they correspond to B tends to 0. Yeah, that is the impact parameter is 0. So there are two limiting cases. So there there are two limiting cases for the impact parameter. Number one, B tends to 0. This would imply the deflection angle. That is, this would imply the deflection angle either theta is equals to 0 or theta is equals to pi. दो ही बातें हो सकती हैं, ठीक है ना? B is equals to 0 पर deflection angle theta is 0. That is, theta is equals to 0. And what is that correspond to? For the attractive potential. So we have a bound state. Yeah. Attractive potentials. Since why is that attractive potential? Since there is no sideways scattering or sideways force acting on some particle, which is basically hitting on some spherically symmetric potential in some head-on sort of manner. Yeah, since uh, since there is no sideways force, acting on a particle hitting a spherically symmetric potential in an head-on manner. In an head-on manner. So this is first case. केस नंबर 2 क्या हो जाएगा? इसमें आप पाई का भी तो केस डिफाइन कर दी. So ये तो थीटा इज इक्वल्स टू 0 था. Similarly we can define for the same b is equals to 0 के लिए theta is equals to pi. Similarly for purely repulsive potential, repulsive potential, that would imply uh, pi, sorry, theta is equals to pi, yeah, since the particle is reflected, particle is reflected backwards. So this is case number one. Case number two, b tends to infinity, yeah. B tends to infinity का मतलब है कि the deflection angle is zero. Uh, Deflection angle is zero again, but now uh, due to the fact that the asymptotic potential is weak. Yeah. So क्योंकि b tends to infinity का मतलब the particle is very far away from the target. That is the perpendicular distance between the axis of interaction and the incoming beam of particle is tending towards infinity. Now again the deflection angle would be zero. Why deflection angle zero? Because the interaction is very weak. Asymptotic interaction is weak, so there would not be an appreciable interaction. However, large impact parameter may contribute significantly to small angle scattering. We could think about such large impact parameter scattering as those which corresponds to small angle scattering. But nevertheless, the scattering deflection angle would be very small. So the deflection angle is zero. Again zero. Uh, Rather again. But why is that? But now it is zero due to किसकी वजह से? Due to the fact that that the asymptotic potential is weak. Tick potential is weak. However, वीक पोटेंशियल होने का मतलब ये कि मतलब ये नहीं है. We are talking about microparticles, yeah, and interactions in the domain of atoms and molecules. So b tends to infinity का मतलब ऐसा नहीं है कि it is these distances corresponding to meters or kilometers, but in comparison to the atomic diameters or molecular diameters हम ये b tends to infinity कर रहे हैं. ठीक है ना? तो इसका यहाँ पर मकसद अगर हम कह रहे हैं बी पैरामीटर विच इज द परपेंडिकुलर डिस्टेंस between the axis of in fact target particle and the beam of incoming particles. Agar this b is tending towards infinity, then deflection angle is zero. This corresponds to weak asymptotic potential. बट इसका ये मतलब नहीं है कि अगर बी टेंडिंग टू इन्फिनिटी पर असिम्प्टोटिक पोटेंशियल वीक है, इसका मतलब ये नहीं है कि स्कैटरिंग नहीं होगी, बट दिस वुड करस्पॉन्ड टू स्कैटरिंग विच आर ऑल्सो नोन एज स्मॉल एंगल scattering. So we want to emphasize here there would be scattering, but that would be known as small angle scattering. However, large impact parameter may contribute significantly to small angle scattering. Yeah, so these are in fact some of the general properties जो हमने डिस्कस की. इसी तरह से फाइनली जो हम ये जो क्लासिकल अप्रोच कर रहे हैं, फाइनली हम जो करना चाहते हैं वो ये कि what would be the classical analog of cross section and what would be the classical analog of differential cross section, जो कि हमने लास्ट सैटरडे को किया था। यहाँ से आपको इनफैक्ट क्लासिकल डिस्क्रिप्शन मिल जाएगा, और उस क्लासिकल डिस्क्रिप्शन को हम इनफैक्ट इस्तेमाल करेंगे in order to sort of correspond to quantum descriptions of scattering cross sections and differential scattering cross section. So जो actual experiments होते हैं ना, जब आप experiments perform करते हैं in some accelerator or some devices where microparticles are interacting with each other. So in such actual experiments, we cannot control the impact parameter on a molecule scale, जैसे कि हम बात कर रहे हैं यहाँ पर, yeah. So we cannot say that the impact parameter is of obviously one atomic diameter or two atomic diameter or three atomic diameter. So we cannot control. What we basically do in some actual experiment, we sort of impinge a beam of particles, and there are random impact parameters, and those random impact parameter beam of particles then interact with the target particle. दूसरे एक और बात, we do not learn much from the passage of a single particle. So what we are interested in is, in fact, many particles are interacting with many other particles, or many particles are interacting with the target. So we do not learn much from the passage of a single particle. Either we only learn it if it was if it was scattered or not scattered. यानी अगर suppose if there was some single particle, then we would only learn in that whether it is a scattered or whether it is not scattered, and those single particle, whether they are scattered or not scattered, they can be studied in a cloud chamber, where you could see the path of the incoming particle not being scattered or scattered, if we just talk about a single particle. Yeah. So दो बातें बड़ी अहम हो गई यहाँ पर, कि किसी भी स्कैटरिंग एक्सपेरिमेंट के अंदर हम जो इम्पैक्ट पैरामीटर है उसको कंट्रोल नहीं कर सकते। दूसरी चीज, हम सिंगल पार्टिकल स्कैटरिंग की मदद से हम बहुत कुछ नहीं सीख सकते अबाउट द टारगेट पार्टिकल। अगर हम सीख भी सकते हैं अबाउट टारगेट पार्टिकल, वो सिर्फ इतना, दैट इज द पार्टिकल इधर इज स्कैटर्ड और इज नॉट स्कैटर्ड। सिर्फ दो बातें हो सकती हैं। सो लेट्स discuss about these things. So they are basically they would be classical analogs of scattering cross section. जो एक्सपेरिमेंटल सेटअप आप बनाते हैं इन सम लैब और सम जैसे एक्सेलरेटर्स हैं, या जैसे कोई क्लाउड चैम्बर है जिसके अंदर बीम ऑफ अल्फा पार्टिकल्स और गैमा रेज पास हो रही हैं. So in those typical experimental setup, those typical setup would consist a beam of particles, not a single particle, but rather a beam of particle, and they have well-defined velocities. That is, we know the velocities. That's why हमने कहा कि जो हम थीटा, जिसको डिफ्लेक्शन एंगल कह रहे हैं, that would be determined as a function of the impact parameter and the incoming particle की velocity. So rather than a single particle, actual experimental setup के अंदर there would be a beam of particles, and those beam of particles would have a well-defined velocity, and they are entering into some gas of target particles. Yeah. दूसरे, the particle, they would impinge on the particles with all possible values of impact parameter. जैसे हमने कहा ना कि कोई एक impact parameter नहीं होगा. These particles or a beam of particles would, when enter into the gas of target particles, they will have all possible values of impact parameters. फर्दरमोर, जो आपके पास आप जो डिटेक्ट करेंगे, यानी जो प्रोजेक्टाइल्स आप आउटगोइंग बीम के अंदर डिटेक्ट करेंगे, they would have a specific path in some cloud chamber, जो कि एक तरह का डिटेक्टर का काम करेगा. या अगर आपने कोई सॉलिड स्टेट सेंसर और डिटेक्टर लगाया हुआ है, then they will basically count those number of particles which are scattered from the target. Therefore, जो जो experiment है, that would experimentally effectively repeat the single collision experiment many times. और इस many times repetition की वजह से you would be able to measure different scattering parameters. Yeah. सो बुनियादी तौर पर हम यहाँ पर बी की वैल्यू कैलकुलेट करना चाहते हैं.